Okay, this is lesson 6.5, Rhombi and Squares. Starting on page 435. Number 1, quadrilateral ABCD is a rhombus. Find each value or measure. If the measure of angle BCD is 64, find the measure of angle BAC.
You want to take this off me, Dada?
So, for a rhombus, the diagonals bisect opposite angle pairs, and as a matter of fact, in a rhombus, it turns out that all 4 of these angles will be congruent. So basically all we have to do is take half of 64, since BCD is this entire angle, and we want to find half of that because the diagonal splits that angle in half. So half of 64 is 32 degrees. Okay, so in this proof, we are given that ABCD is a rhombus with diagonal DP. Okay, so based on the fact that it is a rhombus, the diagonals will bisect the angles. So we know that APB is congruent to angle CPB. Diagonals of a rhombus bisect angles. So we have that those 2 angles are congruent. We also know that PB is congruent to PB by the reflexive property. And we also know that by the definition of a rhombus, all sides are congruent. So AB is congruent to CB. Therefore, we can say that triangle APB and CBP are congruent by side, angle, side, since we have 2 sides and the included angle of one triangle congruent to 2 sides and the included angle of the other triangle. And now, since those 2 triangles are congruent, then their corresponding parts will be congruent, and AP corresponds to CP. So those 2 sides are congruent by CP/CTC. Corresponding parts of congruent triangles are congruent. Okay, given each set of vertices, determine whether QRST, parallelogram QRST, is a rhombus, a rectangle, or a square. List all that apply and explain. So, the first thing that we want to check for is a right angle at the intersection of two sides, because we have a theorem that states that if a parallelogram has a right angle, then all four angles will be right angles, which will mean that a parallelogram with four right angles is a rectangle. So we're first checking to see if it is a rectangle. So I like to have a picture, so I'm just going to draw just a quadrilateral here and label it in consecutive order, QRST. It doesn't really matter as far as if I'm getting these in the right place coordinate-wise, just as long as QRST are consecutive. So if I want to know if this angle is a right angle, then I want to check to see if QR is perpendicular to RS. And to check that, we need the slopes of QR and RS. So the slope of QR, so that would be my change in y over change in x. So for my y coordinates, I would have -1 for R, 2 for Q, and the change in x coordinates for my R is -2, and for my Q is 1. So if I simplify this, I would have -3 over -3, which is equal to +1. Then we want the slope of RS. So for my S, my y coordinate is -4. For my R, my y coordinate is -1. Then my x coordinates, S, and for R, -2. And if I simplify this, that would become +1, so that is -3 over 1. This would become +2 over 3, so that's equal to -1. And if I multiply 1 times -1, I get a product of -1. So anytime the product of the slopes is -1, then we know that the two lines are perpendicular. So we've just shown that this parallelogram has a right angle, which means that all angles are right angles. So we know that our parallelogram is at least a rectangle. And to explain that, consecutive sides are perpendicular. And so let's continue on here. So to determine if the parallelogram is a rhombus, we have a theorem that states that if consecutive sides are congruent, then the parallelogram is a rhombus. So we want to see if the lengths of QR and RS are the same. So we need the distance formula for that. So first for QR, we have our x coordinates are 1 and -2. And the y coordinates are 2 and -1. And if we simplify, see, this would become +2, so that is 3 squared. And this would become +1, so that is also 3 squared. So that is the square root of 9 plus 9, or the square root of 18. So let's see if we get the same thing for the length of RS. So my x coordinates are -2 and 1. And my y coordinates are -1 and -4. And so let's simplify this. So we get -3 squared plus, this would be +4, so that is 3 squared. And once again, it just works out to the same thing. We get the square root of 18. So what have we just shown there? We've shown that consecutive sides are congruent, which means that all 4 sides are congruent, which means that it is a rhombus. And since it is a rectangle and a rhombus, we have a theorem that states that it will be a square. So it is a rectangle, rhombus, and square. Quadrilateral ABCD is a rhombus. Find each value or measure. Number 7, AB is 14. So find BC. Well, consecutive sides of a rhombus are congruent. So BC is 14 as well. Number 9, if AP is 3x minus 1, and PC is x plus 9, we want to find AC. So since we know that all rhombuses are parallelograms, then we know that the diagonals bisect each other. That's a property of a parallelogram, so it will be a property of a rhombus as well. So that means that these two segments have to be congruent, so we can set them equal. So subtract x from both sides, and add 1 to both sides, and divide both sides by 2. And x is equal to 5, but we are asked to find the length of AC. So we can substitute into both of them and add them together, or we can just substitute into one side since they're equal and double it. So I'll just substitute into one side. So PC is x plus 9. So PC is equal to 5 plus 9, which is 14. So if I multiply that by 2, AC is equal to 28. Next, we're given the measure of angle ABC. This entire angle is 2x minus 7. And BCD, this entire angle, is 2x plus 3. And we want to find the measure of angle DAB. So DAB will be the same as BCD, since opposite angles are congruent. So once we find x, we'll just substitute it in for 2x plus 3. But to set up our equation, we know that the consecutive angles of any parallelogram are supplementary. So if we add these two expressions together and set it equal to 180, we can solve for x. So if we combine our like terms, we'll get 4x minus 4 equals 180. And 4x is equal to 184. And so x is equal to 46. Next, we want to find the measure of angle DAB, which is equal to the measure of angle BCD, which is 2x plus 3. So 2 times 46 plus 3 is 95. number 13, we're given that WZ is parallel to XY, WX is parallel to ZY, and WZ is congruent to ZY. So I always like to mark that information in the diagram. So these two sides are parallel. These two sides are parallel. And WZ is congruent to ZY. Okay, since both pair of opposite sides are parallel, then we know that this is a parallelogram. And this is a pretty short proof. So we have a theorem that states a parallelogram with consecutive congruent sides is a rhombus. So we can say WXYZ is a rhombus by the reason I just stated. Okay, in this proof, we're given that JKQP is a square and ML bisects JP and KQ. So if we know that JKQP is a square, then it must be a parallelogram because all squares are parallelograms. And there's the symbol for parallelogram. Therefore, by definition, its opposite sides will be parallel. So JM is parallel to KL. We also know that opposite sides of a parallelogram are congruent, so we know that JP is congruent to KQ. And by the definition of congruent segments, we know that the length of JP is equal to the length of KQ since they are congruent. By the definition of bisects, we know that JM is equal to MP and KL is equal to LQ because ML bisects JP and KQ, so it splits it into two congruent parts. By the definition of bisects. By the segment addition postulate, we know that JP is equal to JM plus MP and KQ is equal to KL plus LQ. And by substitution, since Jm is equal to MP, we can substitute Jm for MP. And we can also substitute KL in for LQ. So then by substituting, we would just get Jm plus Jm or 2Jm and KL plus KL or 2KL. And so once again by substitution, we would have 2Jm is equal to 2KL because we know that JP and KQ are equal to each other, so we can substitute this in place of JP and this in place of KQ. And by the division property of equality, we can divide both sides by 2. And by the definition of congruent segments, therefore we can say that KL is congruent to JM. And finally, we can say that since JM is parallel and congruent to KL, we can say that JKLM is a parallelogram because if one pair of opposite sides is congruent and parallel, if one pair of opposite sides is congruent and parallel, then the quadrilateral is a parallelogram. Okay, so if one pair of opposite sides is congruent and parallel, then the quadrilateral is a parallelogram. For number 17, Main Street and High Street intersect as shown in the diagram. Each of the crosswalks is the same length. Classify the quadrilateral formed by the crosswalks and explain your reasoning. So if all four lengths of a quadrilateral are the same, then we have a rhombus. And it's just by that reason. Since the crosswalks are the same length, the sides of the quadrilateral are congruent, therefore they form a rhombus. Given each set of vertices, determine whether parallelogram JKLM is a rhombus, a rectangle, or a square. List all that apply and explain. So I've worked out one of these before. So the first thing, I'm just going to make a quadrilateral here and label my vertices in consecutive order. So JKLM. Also, I'm going to draw the diagonals. So, the main thing that we need to look at here is the diagonals. If the diagonals are perpendicular, then we know that the quadrilateral is a rhombus. Or, I'm sorry, the parallelogram is a rhombus. And if the diagonals are congruent, then we know that the parallelogram is a rectangle. And if it is a rhombus and a rectangle, then it is a square. So the first thing I'm going to check is to see if JL is perpendicular to MK. So I need their slopes. So the slope of JL will be equal to my change in Y, so that is -1 minus 3 over my change in X, -4 minus 4. And I get 1/2. Then I'm going to look at the slope of KM. So my change in Y, -1 minus 3, and my change in X, 1 minus -1. And the product of the slopes is equal to -1, which means that my two lines are perpendicular. So we know that, that this is a rhombus. Since the diagonals are perpendicular. But before we're done, we also need to see if the diagonals are congruent. So we need the distance between J and L. So my x's are -4 and 4. And my y's are -1 and 3. So simplify this a bit. So we get the square root of 80 for the length of JL. Let's also find the length of KM. So my x's are 1 and -1. And my y's are -1 and 3. So if I simplify that, I would get 1 plus 1, or 2 squared, and -1 minus 3, or -4 squared. And so I get the square root of 20. So obviously, square root of 80, square root of 20 are not the same. So my diagonals are not congruent, which means that this would not be a rectangle or a square. It is simply a rhombus. Okay, for 21, I'm going to use the same test. So to see if it is first a rhombus, I need to see if my diagonals are perpendicular. So I need the slopes of JL and KM. So first, the slope of JL. So my change in y, my y's are -1 and 3. And my change in x. So my x's are -4 and 4. Oh, I'm sorry, I was looking at the wrong one. Back up here. Okay, just to double check. So my slope of JL. So I need my change in y. So -1 and 5. And my change in x. So -2 minus 1. So my slope of JL is 2, and I also want my slope of KM. So for K and M, my y's are 3 and 1, and my x's are -4 and 3. And the product of 2 and -2/7 would not be -1. Therefore, my diagonals are not perpendicular, which means that it is not a rhombus. Therefore, it cannot be a square, but we need to also check to see if it's a rectangle. So we need to see if the diagonals are congruent. So the length of JL So for J and L, my x's are -2 and 1. And for J and L, my y's are -1 and 5. And my length is the square root of 45. So let's see if the length of KM is the same. So for K and M, my x's are -4 and 3. And for K and M, my y's are 3 and 1. And so my length is the square root of 53, which is not equal to the square root of 45. So the diagonals are not congruent, so it is not a rectangle. So it is none. None of the above. It is not a rhombus, a rectangle, or a square, because the diagonals are neither perpendicular nor congruent. In the diagram, ABCD is a rhombus, PB is 12, I've already marked this in my diagram, AB is 15, and the measure of angle ABD is 24 degrees. Find each measure. So to find the length of AP, we know that the diagonals of a rhombus are perpendicular, which means that I have a right triangle here where my hypotenuse is 15, so I can apply the Pythagorean theorem. So AP, I'll just call that A, so A squared, plus my other leg is 12, so it's plus 12 squared, is equal to my hypotenuse, 15 squared. So A squared plus 144 is equal to 225, and if I subtract 144 from both sides, I get A squared is equal to 81, and A is equal to 9. So AP will be 9. For number 25, I need the measure of angle BDA. So BDA would be this angle right here. And the other special quality of the diagonals of a rhombus is that they bisect opposite angles. So it's going to split these two angles into two congruent angles, and these two angles into this angle into two congruent angles. And as a matter of fact, all four, this angle, this angle, this angle, and this angle, will be the same in a rhombus. So if we know the measure of one, then we know the measure of 1, 2, 3, 4. So this will also be 24 degrees. WXYZ is a square. If WT is 3, find each measure. So for number 27, we want to find the length of ZX. In a rectangle, and therefore also in a square, all four of these lengths will be the same, which means that all four of them are 3. So ZX is 3 plus 3, or 6. For number 29, the measure of angle WTZ. WTZ is this angle right here, and in a rhombus, and therefore also in a square, the diagonals are perpendicular, and perpendicular lines form right angles, so WTZ is 90 degrees. Classify each quadrilateral. Number 31, it says that all four of these parts are congruent, which means that my diagonals are congruent, which makes it a rectangle. And also we have a right angle here, so the diagonals are perpendicular, which makes it a rhombus. And if it is a rectangle and a rhombus, then that means that it is a square. For number 33, opposite sides are congruent, so it is a parallelogram. And we have a right angle down here. So if a parallelogram has a right angle, then all four angles are right angles, which means that it is a rectangle.